In the last lecture, we were studying the problems which are based on the complementary function and particular integral. The main intention over there was to use the short methods for finding pi. Though one or two types of problems which are still remaining, we have considered up till now only the problems which happen to be the product of only two terms on the right hand side. It is quite possible that you might have more than two terms in multiplication on the right hand side of the given differential equation. Let us go ahead and learn one more method, which is altogether a separate method for solving the differential equations. It is called as method of variation of parameters. It is variation of parameters. The method should be understood thoroughly. There is no formula which is to be used for pi. It will work on certain assumptions, and we have got even the restriction for the number of assumptions also. I will be giving you the entire procedure, but that procedure will be written simultaneously when we try to solve the problem. For example, we want to solve a problem that is a differential equation which is in the form d square plus a square operating on y equal to sec ax. Recall that we have got formulae only for e raised to ax type of terms or sine or cos or polynomials. We did not have any formula, any short method for finding pi where the right hand side involves a term like sec ax, cosec ax, tan x and so on. Generally in all these cases we are required to use the method of variation of parameters. This method says that if the given differential equation is like d square plus a square operating on y equal to sec ax, then first step will be to find CF. I will be writing down the steps as well as I will be implementing those steps. So the steps for solving the problem of method of variation of parameters. First step will be find complementary function. No change in that. So in this case, for CF, we have d square plus a square operating on y equal to 0, which is nothing but the auxiliary equation. And so d square plus a square equal to 0, d square equal to minus a square, d equal to plus or minus ia, and therefore CF will be C1 cos of ax plus C2 sine of ax. That is going to be the CF. Now step number 2 says that replace arbitrary constants from CF by functions of x, say u, v, etc. This is going to be our assumption number 1. Remember, we are required to do two assumptions in this case because the given differential equation is of second order. So we say that let y is equal to pi is equal to u cos ax plus v sin ax. This is going to be equation number 1. We can also treat this as assumption number 1. Third step says that find d of y. So this particular y that we have assumed, that should be differentiated. So d of y will be equal to, remember that u and v are functions of x. So it is going to be the product that is to be differentiated using u into v rule, that is u into dv by dx plus v into du by dx. So it will be u into cos ax is differentiated as minus a sin ax, plus differentiation of u is u dash cos ax, plus v sin ax also will be differentiated, and it will be v into a cos ax plus v dash sin ax, which is our equation number 2. So this is equation 2. Step number 4 says that equate terms containing u dash, v dash, etc. to 0. That is going to be our equation number 3, actually assumption number 2. So in this case we have two such terms, u dash cos ax and v dash sin ax. So we say that let u dash cos ax plus v dash sin ax is equal to 0, which is our equation number 3, assumption number 2. Next step, of course, is to rewrite dy. That is, excluding these terms, we should be writing equation 2 again. Step says that rewrite dy. So now dy will be minus au sin ax plus av cos ax, which is our equation number 4. It is the procedure which is to be followed for solving the problem. Step number 6 says find d square y. So dy that we have written just now, that should be again differentiated. Dy was minus au sin ax plus av cos ax. So d square y will be equal to minus a into bracket a into minus a into bracket u into bracket a cos ax plus u dash sin ax, that is the first term, plus a into bracket v into bracket minus a sin ax plus v dash cos ax. If we just simplify it and write it again, it will turn out to be minus a square u cos ax minus a u dash sin ax minus a square v sin ax plus a v dash cos ax, which is going to be equation number 5. So rewriting dy, we got equation number 4. Finding d square y, we get equation number 5. In step 7 we say that using 5, that is equation number 5, we'll just name them as E5, E6 and so on. So using equation 5, equation 4 and equation 1, equation 5, equation 4 and equation 1, substitute in given differential equation. Now in this case we had the differential equation of the type, let me rewrite here, d square y plus a square y equal to sec ax. So the differential equation was d square y plus a square y equal to sec ax, and if we substitute d square y it will be minus a square u cos ax minus a u dash sin x minus a square v sin x plus a v dash cos x. This is what we have substituted for d square y, plus a square into bracket y, that was pi that we have assumed was u cos ax plus v sin ax, that was through equation 1, equal to right hand side sec ax. And this is going to be our equation number 6. So, using E5, E4 and E1, substitute in the given equation to get E6. And remember, here is a cross check that the terms containing only u and v should get cancelled. If this cross check is not followed, then probably your procedure or your calculations have gone wrong. The terms containing u and v should get cancelled, not u dash and v dash. Now observe that in equation 6 we have minus a square u cos ax and plus a square u cos ax, they cancel. We have minus a square v sin ax and plus a square v sin ax, so these two cancel, and equation 6 turns out to be only minus a u dash sin ax plus a v dash cos ax equal to sec ax. I am just rewriting equation number 6 only. So the procedure was assume y by replacing the arbitrary constants by functions of x, that is u, v, etc. From that y, that was our first assumption, find out dy. Then from dy equate the terms containing u dash v dash to 0, that was our assumption number 2. We will rewrite dy, find d square y and substitute all this collection into the given differential equation with the cross check that terms containing u v should get cancelled. The next step says that solve E6 and E3, that is the current equation that we have got and our assumption number 2 simultaneously. To find u dash and v dash. So we have equation 6, we have just written it. So equation number 3 was u dash cos ax plus v dash sin ax is equal to 0. That was equation number 3. And equation number 6 is minus a u dash sin x plus a v dash cos x minus sec x equal to 0, equation number 6. These two are to be solved simultaneously to find u dash and v dash. Now the procedure for solving should not be the one which we are always following. Instead of that, we can use the determinant technique. It will be u dash divided by the coefficients of the other two terms, which are namely sin ax 0, a cos ax and minus sec ax, equal to, it is alternate plus minus, minus v dash upon, so skip the coefficients of v dash, it will be cos ax 0 minus a sin x minus sec x is equal to 1 upon coefficients of u dash and v dash, which is cos ax sin ax minus a sin x and a cos ax. And so if we just write it properly, it will be u dash upon sin ax into sec ax. Sec is 1 upon cos, So it is sine into 1 upon cos, that is tan ax with minus sign. So it is minus tan ax u dash upon minus tan ax minus 0 of course, equal to minus v dash upon cos ax into sec ax will be 1, original minus sign is already there, equal to 1 upon, it will be a cos square ax and minus minus plus a sin square ax. Of course, a can be taken common, sin square plus cos square will be 1. And so we get it as u dash upon minus tan ax equal to v dash upon 1 equal to 1 upon a. And therefore, u dash will be written as minus 1 upon a tan ax and v dash will be written as 1 upon a. So our aim was to solve equation number 6 and 3 to find u dash and v dash. Next step says that integrate u dash to get u and v dash to get v. So we are required to integrate u dash and v dash independently. So u will be equal to integral u dash dx, that is integral minus 1 upon a tan ax dx. So it is minus 1 upon a, integration of tan is log of sec ax, so it will be log of sec ax, minus sign can be absorbed, so it is 1 upon a log of sec ax raised to minus 1, which is 1 upon a log of cos ax. And v will be equal to integral v dash dx, which is equal to integral 1 upon a dx, which will be simply x upon a. So our step number 9, which was saying that integrate u dash to get u and v dash to get v, is over. Then it is said that substitute u and v in assumption 1. So where we have assumed pi, that was u cos ax plus v sin ax, in that we are required to substitute these values of u and v. So it was pi that we had assumed as u cos ax plus v sin ax can now be written as 1 upon a. I suppose there is a small mistake in the integration. When tan ax was integrated, it was log of sec ax upon a should be there. So this will become a square. And so it will be 1 upon a square log of cos ax into cos ax plus x upon a sin ax. And so the final answer in step number 11 will be y equal to Cf plus Pi. Final answer is y equal to Cf plus Pi. And so the solution for the given differential equation will be C1 cos ax plus C2 sin ax plus cos ax upon a square plus, or rather into log of cos ax plus x sin ax upon a. So method of variation of parameters is the one where the entire procedure is stated with the cross checks and we should be getting the solution. Let us have a look at the entire procedure and try to recap as how we were solving the problem. The problem that was given to us was d square plus a square operating on y equal to sec ax. We are required to find by the first step CF, and CF will be in this case d square plus a square being 0, d equal to plus or minus ia. Those were the complex roots. Alpha is 0 and beta is 1. So CF comes out to be C1 cos ax plus C2 sin ax. Step number 2 says that we are required to replace the arbitrary constants C1 and C2 by functions of x, say namely u and v. And so our assumption number 1 in this case, it will be y equal to pi equal to u cos ax plus v sin ax. That is our equation number 1. Next step says that find dy, that is differentiate the assumed y. U and v being functions of x, when we differentiate we get it as u into minus a sin ax plus u dash cos ax plus v into a cos ax plus v dash sin ax. We have got 4 terms in dy. I repeat, y equal to u cos ax plus v sin ax was the assumed pi, and so dy will be equal to u into minus a sin ax plus u dash cos ax plus v into a cos ax plus v dash sin ax. That is our equation number 2. Next step says that the terms containing u dash and v dash from this dy should be equated to 0, and there are 2 terms, namely u dash cos ax and v dash sin ax. So our assumption number 2 will go here, where we are saying that let u dash cos ax plus v dash sin ax is equal to 0. Once we make these terms of u dash v dash as a 0, we are required to rewrite dy, which in this case will come out to be dy equal to minus au sin ax plus av cos ax. As we get dy, which happens to be our equation number 4, we are required to find d square y, that is through the differentiation of the current term, that is minus au sin ax plus av cos ax. Once we find d square y, then we are required to substitute d square y, dy and the assumed value of y in the given differential equation and obtain equation number 6 with the cross check that the terms containing u and v should get cancelled. So we get equation number 6 in the rewritten form, which is something like it was the terms containing a square u and a square v were getting cancelled, and it was simply the differentiation on the left hand side which was giving me the terms like it was u dash cos ax plus v dash sin ax was equated to 0 in assumption 2, and so the last equation will turn out to be minus au dash sin ax plus av dash cos ax equal to sec ax. That was our equation number 6. And equation 3 and assumption 2, they were solved simultaneously to obtain u dash and v dash. And after integrating u dash v dash, we will get uv, which are to be substituted in the assumption, and y equal to cf plus pi was the given solution. Let us solve 1 or 2 problems more. It is easy to identify the problem because the right hand side will not be one of the standard functions which we are using in the short methods for finding pi. It is not going to be any term like e raised to ax, it is not going to be any polynomial. There will be terms like sec ax, tan ax, cosec ax, or even some functions of e raised to ax might come into picture. Like you can have e raised to ax, there could be some term like sine of e raised to ax, and so on. All these are the indications that the problem should be solved by variation of parameters. Let us consider a problem. It is d square plus 4 operating on y equal to 4 sec square 2x. Procedure says that find CF. So for CF, it is d square plus 4 operating on y equal to 0. So d square plus 4 equal to 0, d equal to plus or minus 2i. CF will be equal to c1 cos 2x plus c2 sin 2x. No number given to this CF. We go with our first assumption, let y equal to pi equal to u cos 2x plus v sin 2x, replacing the arbitrary constants by functions of x and y. Equation number 1. From this, find out dy, that is differentiated. So it is u into minus 2 sin 2x plus u dash cos 2x plus v into 2 cos 2x plus v dash sin 2x. Equation number 2. The terms containing u dash and v dash from this should be equated to 0. So we say let u dash cos 2x plus v dash sin 2x is equal to 0. Equation number 3. And we rewrite dy, which will now come out to be minus 2u sin 2x plus 2v cos 2x is equal to 0. Equation number 4. Which is to be differentiated further to find out d square y. So it will be minus 2u into 2 cos 2x minus 2u dash sin 2x plus 2v into minus 2 sin 2x plus 2v dash cos 2x. I am just rewriting it. So it will be minus 4u cos 2x minus 2u dash sin 2x minus 4v cos 2x minus 4v sin 2x plus 2v dash cos 2x, which is our equation number 5. We are required to substitute this value of d square y in the given differential equation, which was d square y plus 4y is equal to 4 sec square 2x. So d square y, when we substitute, it is minus 4u cos 2x minus 2u dash sin 2x minus 4v sin 2x plus 2v dash cos 2x, that was the value of d square y, plus 4 into bracket, through assumption 1 y should be substituted, which is with u cos 2x plus v sin 2x equal to 4 sec square 2x. And you will find that terms containing u and v are again getting cancelled, and we are left with minus 2u dash sin 2x plus 2v dash cos 2x equal to 4 sec square 2x. After cancelling 2, I can write the equation as minus u dash sin 2x plus v dash cos 2x equal to 2 sec square 2x, which is our equation number 6. This equation number 6 should be solved simultaneously with assumption number 2, that was u dash cos 2x plus v dash sin 2x equal to 0. And for that we are writing the equations as u dash cos 2x plus v dash sin 2x plus 0 equal to 0. And equation 6 is written as minus u dash sin 2x plus v dash cos 2x minus 2 sec square 2x is equal to 0. These are to be solved simultaneously using our determinant technique. It is u dash upon sin 2x 0 cos 2x minus 2 sec square 2x equal to minus v dash upon coefficients of u dash as first column, that is cos 2x and minus sin 2x, and the constants, which is 0 and minus 2 sec square 2x equal to 1 upon coefficients of u dash and v dash, which is cos 2x minus sin 2x, sin 2x and cos 2x. When we solve this, it will be u dash upon sin into sec square, minus 2 is already there. So sin into sec square, 1 sec will remain and 1 sec, that is 1 upon cos, will merge with this sin to form tan. It is minus 2 sec 2x tan 2x equal to minus 1 upon cos into sec square. Sec square is 1 upon cos square, so 1 cos will cancel and 1 sec will remain. It will be minus 2 sec 2x equal to 1 upon cos into cos is cos square, minus minus plus sin square, cos square plus sin square is 1. And so we get value of u dash as minus 2 sec 2x tan 2x, and we'll get value of v dash as 2 sec 2x. So this u dash and v dash is to be integrated to find out u and v. This u dash and v dash should be integrated to find u and v, and therefore u will be equal to integral u dash dx, which will be equal to minus twice integral sec 2x into tan 2x dx, and integration of sec 2x tan 2x is sec 2x upon 2. So ultimately u comes out to be minus sec 2x, and v will be integral v dash dx, which will be integral of 2 sec 2x dx. Integration of sec is log of sec plus tan, so it will be twice log of sec 2x plus tan 2x divided by the coefficient, which is 2, which cancels. And therefore pi, which was assumed as u cos 2x plus v sin 2x, can now be written as minus sec 2x into cos 2x plus log of sec 2x plus tan 2x into sin 2x. Again sec into cos will be 1, so this will be minus 1 plus sin 2x into log of sec 2x plus tan 2x. That is going to be pi. And y equal to cf plus pi will be the required answer. So final answer comes out to be y equal to c1 cos 2x plus c2 sin 2x minus 1 plus sin 2x into bracket log of sec 2x plus tan 2x. So method of variation of parameters is one which is very simple and straightforward. Any sign mistake or calculation mistake that can be very well indicated at the cross check level, that if the terms containing uv don't get cancelled, then you have made some mistake. After that, what remains is solving the simultaneous equations and getting the values of u and v. There are almost 6 to 7 problems which go in this particular category, that is variation of parameters, and generally they are repeatedly asked in the exam. We have already solved 2 of those problems. Let us proceed to solve the next problem in the variation of parameters, which is given as d square minus 1 operating on y is equal to 1 plus e raised to minus x bracket raised to minus 2. Procedure remaining the same. Our first step will be obviously to find CF, and for CF it is d square minus 1 operating on y will be equal to 0, and so d square minus 1 will be equal to 0. So for CF it is d square minus 1 operating on y equal to 0, So d square minus 1 equal to 0, d equal to plus or minus 1, Cf will be equal to C1 e raised to x plus C2 e raised to minus x. Once we find Cf, then the arbitrary constants C1, C2, etc. should be replaced by functions of x, namely u, v, and so on. And therefore, our first assumption says that let y equal to pi is equal to u e raised to x plus v e raised to minus x. Assumption number 1, equation number 1. Find dy. So dy will be equal to u into e raised to x ka differentiation is e raised to x plus differentiation of u is u dash e raised to x plus v into differentiation of e raised to minus x is minus e raised to minus x plus v dash e raised to minus x. That will be our equation number 2. From this second equation, we are required to equate terms containing u dash v dash to 0, and therefore our next assumption comes into picture. It will be let u dash e raised to x plus v dash e raised to minus x is equal to 0, equation number 3, assumption number 2. Rewrite dy. Therefore, dy will be written as u e raised to x minus v e raised to minus x, equation number 4, which is to be further differentiated to find d square y. And so d square y will be equal to u into differentiation of e raised to x, which is e raised to x plus u dash e raised to x, minus v into differentiation of e raised to minus x is minus e raised to minus x, minus differentiation of v is v dash into e raised to minus x. A little adjustment over here. For signs, it is u e raised to x plus u dash e raised to x minus minus plus v e raised to minus x minus v dash e raised to minus x, equation number 5. This particular value of d square y and our first assumption y should be substituted in the given differential equation, and that given differential equation was d square y minus y equal to 1 plus e raised to minus x bracket raised to minus 2. So as we substitute, it will be u e raised to x plus u dash e raised to x plus v e raised to minus x minus v dash e raised to minus x minus into bracket u e raised to x plus v e raised to minus x, that was our assumed y, equal to 1 plus e raised to minus x bracket raised to minus 2. The same condition will hold good, that the terms containing uv should get cancelled, and as they cancel out, we say that whatever we have done up till now is the correct one, and we are left with u dash e raised to x minus v dash e raised to minus x equal to 1 plus e raised to minus x bracket raised to minus 2 as equation number 6. We are required to solve the two equations, that is equation number 6 and assumption number 2, that was equation number 3, simultaneously to find out u and v, rather to find out u dash and v dash. So equation 3 was u dash e raised to x plus v dash e raised to minus x plus 0 equal to 0. And the current equation is u dash e raised to x minus v dash e raised to minus x minus 1 plus e raised to minus x bracket raised to minus 2 equal to 0. Now through observation we can say that we don't have to proceed to the method of determinants, because even if we just add these two equations, v dash terms will get cancelled and you will get it as 2 u dash e raised to x is equal to 1 plus e raised to minus x bracket raised to minus 2, and therefore u dash will be equal to 1/2 e raised to minus x into 1 plus e raised to minus x bracket raised to minus 2, value of u dash. From the first equation, that was u dash e raised to x plus v dash e raised to minus x equal to 0, we can say that v dash e raised to minus x is nothing but minus u dash e raised to x. If we multiply throughout by e raised to x, we will get v dash is equal to minus u dash e raised to 2x. And if we use this and substitute u dash, therefore we will get v dash is equal to 1/2 with a minus sign e raised to x into 1 plus e raised to minus x bracket raised to minus 2, value of v dash. Once we solve these two equations simultaneously, then the job that is left with us is to integrate u dash and v dash and to find u and v. Integration at times may turn out to be a difficult one, as it appears right now. With some substitutions it is of course solvable. So let us solve u dash. U is equal to integral u dash dx, which can be written as half integral e raised to minus x into 1 plus e raised to minus x bracket raised to minus 2 dx. Let us write it in our usual form, that is integral e raised to minus x divided by 1 plus e raised to minus x bracket square dx. Substitution suggested by the nature let 1 plus e raised to minus x is equal to t. Therefore, minus e raised to minus x dx is equal to dt, or e raised to minus x dx is equal to minus dt. This will result in half integral minus dt upon t square. So minus half integration of 1 upon t square is minus 1 upon t. So ultimately it is 1 upon 2t, and t can be resubstituted. Answer comes out to be 1 upon 2 into bracket 1 plus e raised to minus x, value of u. And then to find v, v is equal to minus half integral e raised to x into 1 plus e raised to minus x bracket raised to minus 2 dx should be written as minus half integral e raised to x divided by 1 plus e raised to minus x bracket square dx. Now the substitution is not going to hold good, because we don't have e raised to minus x term in the numerator. Because if we make the same substitution, denominator will become t square, and in the numerator you are required to adjust for even e raised to x, which will turn out to be 1 upon t, and it could be slightly difficult. Let us write e raised to minus x as 1 upon e raised to x and see whether we can solve it. It is e raised to x into divided by 1 plus 1 upon e raised to x bracket square dx can be taken outside. So it is half integral e raised to x divided by 1 upon e raised to 2x into bracket e raised to x plus 1 bracket square dx, which will be written as minus half integral e raised to 2x into e raised to x divided by e raised to x plus 1 bracket square dx. Now the substitution is possible. Let e raised to x plus 1 is equal to t. Therefore, e raised to x dx is equal to dt. Of course, the first substitution says that e raised to x indicates that it is t minus 1, if we take 1 on the other side. And so it will be minus half integral e raised to 2x will be written as e raised to x bracket square, that is t minus 1 bracket square. E raised to x dx will be written as dt divided by the denominator will simply turn out to be t square, which will be equal to, in this case, minus half integral, expand the numerator, it is t square minus 2t plus 1 divided by t square dt, and if we divide each term by t square, it will be minus half integral 1 minus 2 upon t plus 1 upon t square dt, the integration of which will come out to be minus half. It will be t minus 2 log t minus 1 upon t. And now we are required to substitute for t as 1 plus e raised to x. And so value of v, which is pretty complicated in this case, v will come out to be minus half into bracket t, that is 1 plus e raised to x, minus 2 log of t, that is 1 plus e raised to x, minus 1 upon t, that is 1 upon 1 plus e raised to x. No need to simplify it further. We are not going to achieve any goal through this. We are required to finally substitute it in the given assumption, or the assumption that we have made in equation number 1, which was y is equal to, rather pi equal to u e raised to x plus v e raised to minus x. Ultimately comes out to be 1 upon 2 into 1 plus e raised to minus x into e raised to x minus half into 1 plus e raised to x minus 2 log of 1 plus e raised to x minus one upon 1 plus e raised to x, the whole thing multiplied by e raised to minus x. Simplification may not be possible. It is e raised to x divided by 2 into 1 plus e raised to minus x minus, if you multiply first term, it will be e raised to minus x upon 2. Second term, e raised to x into e raised to minus x is 1, it will be minus half. Third term, it will be minus minus plus 2 getting cancelled, e raised to minus x log of 1 plus e raised to x. And the last term, it is minus minus plus e raised to minus x divided by 2 into bracket 1 plus e raised to x will be the pi, and y equal to Cf plus pi is the required answer. So howsoever difficult the problem may be, it is always solvable. Further simplification may give us some interesting results, but even if we reach this level, that is fairly okay. Y equal to Cf plus pi, probably this term will get merged with the C2 e raised to minus x term that we have. Constant will stay with us, and from here this term, it can be adjusted with the other term, because we can write this e raised to minus x as 1 upon e raised to x, and that can be taken common, taken to the numerator. Denominator is same, we can multiply and proceed further. Let us solve one more problem. It is d cube plus d operating on y equal to cosec x. D cube plus d operating on y equal to cosec x. Actually, one and the only problem which is normally asked for the cubic. So here we are required to make 3 assumptions. The previous method will hold good only when the order of differential equation is 2. Method remains the same. One more assumption. We are required to equate terms containing u dash and v dash from d square y also to 0. Then rewrite d square y and find d cube y and so on. So for Cf, it is d cube plus d operating on y equal to 0. That is d cube plus d equal to 0. D into bracket d square plus 1 equal to 0. So d equal to 0, d square equal to minus 1, that is d equal to plus or minus I. There are 3 roots. Cf will be c1 e raised to 0x plus c2 cos x plus c3 sin x. E raised to 0x is 1, so Cf is c1 plus c2 cos x plus c3 sin x. Let y equal to pi equal to u plus v cos x plus w sin x. Assumption number 1, equation number 1. We should be differentiating it to find dy. Step number 2, find dy. Differentiation of u is u dash plus v into minus sin x plus v dash cos x plus w into cos x plus w dash sin x, equation number 2. Once we write dy, we can go for one more assumption, that is terms containing u dash, v dash and w dash should be equated to 0, which is our assumption number 2. So let u dash plus v dash cos x plus w dash sin x is equal to 0. Equation number 3, actually assumption number 2. Rewrite dy, and so dy will come out to be minus v sin x plus w cos x, equation number 4. This should be differentiated to find d square y. So d square y will be equal to minus v into cos x minus v dash sin x plus w into minus sin x plus w dash cos x, equation number 5. Being a cubic, d cube term is there, we are required to have one more assumption. So we again go for the same assumption, that is terms containing u dash, v dash, w dash should be equated to 0. And we say that let v dash sin x plus w dash cos x, let v dash sin x, is there anything wrong? Minus v dash sin x plus w dash cos x, okay, fine. Minus v dash sin x plus w dash cos x equal to 0, equation number 6, assumption number 3. And therefore we will write d square y as only the remaining terms, minus v cos x minus w sin x, equation number 7. This should be differentiated to find d cube y, which will be equal to minus v into minus sin x minus v dash cos x minus w into cos x minus w dash sin x, equation number 8. And now we are required to substitute d cube y from equation 8, dy from the rewritten dy, that is equation number 4, and y from equation number 1 in given differential equation, which was d cube y plus dy equal to cosec x. So if we substitute, we get it as v sin x minus v dash cos x minus w cos x minus w dash sin x plus dy terms will be minus v sin x plus w cos x equal to cosec x, with the cross check that the terms containing u and v should get cancelled, u, v, w. V sin x minus v sin x cancel, minus w cos x plus w cos x cancels, and we get it as minus v dash cos x minus w dash sin x is equal to cosec x, rewritten equation number 9. And now we were required to solve simultaneously. So solve, it is equation number 1, 2, 3, that is assumption 1, assumption 2, that is equation number 3, 6 and 9 are to be solved simultaneously, and these equations are respectively u dash plus v dash cos x plus w dash sin x equal to 0, equation number 3. Equation number 6 was minus v dash sin x plus w dash cos x equal to 0, and equation number 9 is minus v dash cos x minus w dash sin x equal to cosec x. These three are to be solved simultaneously. A lengthy problem in a way, but still not a difficult one. though we have got three unknowns over here, u dash, v dash and w dash, observe that to first equation if we add the third equation, we will straight away get the value of u dash, because v dash cos x and w dash sin x will get cancelled. U dash will come out to be only cosec x. So adding 3 and 9, we get u dash equal to cosec x. So out of the 3, we got value of 1. And these two can be as usual solved simultaneously in the determinant form. So let us write them once again. It is minus v dash sin x plus w dash cos x plus 0 equal to 0. And the second one is minus v dash cos x minus w dash sin x minus cosec x equal to 0. Of course, you can make all of them plus. So it will be v dash upon cos x 0 sin x cosec x equal to minus w dash upon minus sin x 0 cos x cosec x equal to 1 upon minus sin x cos x sin x. So it will be v dash upon cos and cosec. Cosec is 1 upon sin, cos upon sin is cot. So v dash upon cot x equal to minus w dash upon sin into 1 upon sin, it is minus 1, equal to 1 upon minus sin square x minus cos square x is minus 1. So v dash comes out to be minus cot x and w dash will turn out to be minus 1. And so we have already got u dash also, that is cosec x. So these three should be used to find out u, v and w. So u will be equal to integral u dash dx, which is equal to integral cosec x dx. Integration of cosec x is log of cosec x minus cot x. We get value of u. V will be equal to integral v dash dx, that is minus integral cot x dx. Integration of cot is log of sin x. If minus sin is absorbed, it will be log of cosec x. And w will be integral w dash dx, which is minus x. And now these three values should be substituted in our assumption number 1 to obtain pi. If you recall, that assumption number 1, that is y equal to pi, that we had assumed was u plus v cos x, I suppose, plus w sin x. And if we substitute, you will get the answer as log of cosec x minus cot x. V, when we substitute, it will be log of cosec x into cos x. And w, when we substitute, it will be minus x sin. And y equal to cf plus pi.